Hello guys, welcome to today's class. Here we'll be looking at Laplace transformation and Laplace transformation introduction. Laplace transformation helps in solving differential equations with boundary values without finding the general solution and the value of the arbitrary constant. Sure you get. And when we say Laplace transform, what is the definition? Let f of t be function defined for all positive value of t. Then f of x. What is f of x? What is f of t? Look up. When I ask you to find the Laplace transformation of f of t, the answer you have is called f of x. So this is you finding the question. This is the answer. When you take the inverse of this, then you get what? F of t back, just like what an opposite. So your f of x, which is the answer you will get when you take the Laplace transformation of a function of t, is derived by taking the integral from boundary 0 to infinity of exponential minus st of the function of t dt. Provided that integral exists, is called Laplace transform of f of t and is denoted as, look at it, it is denoted as the Laplace transform, look at this point, the Laplace transform of f of t is denoted as this L is Laplace transform of function of t. Now if you take the Laplace of this function, the answer will be what? F of x. But how do we get this f of x? Is by taking the integral, look at the standard definition, the integral from 0 to infinity exponential minus st is constant, gbagam. Now multiply with the function you are looking for, dt. So this is the definition of what? Laplace transform of any function for provided the integral exists for all positive value of t. This is the definition of Laplace. Now, since we all know that the definition of Laplace, that is the Laplace transformation of f of t, is equal to the integral from 0 to infinity of exponential minus st f of t dt. Okay, now if I ask you to find the Laplace transformation of if I ask you to find the Laplace, okay, let's start one by one. Find the Laplace transformation of f of t to be equal to 1. Here you get, meaning f of t is 1. So it means find the Laplace transformation of 1. So in place of f of t is what? 1. Therefore, the Laplace transformation of 1 is the integral from 0 to infinity exponential minus st times 1 dt, which is the same thing as the integral from 0 to infinity exponential minus st. Okay, now if we take the integral of that, that should give us 1 over minus x. Don't forget dt with respect to t. So if you differentiate what is there with respect to t, it gives us minus x. So you take the inverse of it as 1 over minus x exponential minus st. Boundary is 0 to infinity. Now, you know, it is with respect to t. I'll be substituting my boundary in place of what? T. So I can say what is here is the same thing as, what is here is the same thing as 1 over minus s into bracket exponential minus s infinity minus exponential minus x is 0. Now is equal to 1 over minus s, look at it, minus s times infinity. Exponential infinity is what? Is 0. That into bracket is 0. Minus s times 0 is 0. Exponential 0 is what? 1. Anything raised per 0 is 1. So this minus 1. So I have it to be 1 over minus x times minus 1 equals to what? 1 over s. Therefore, the Laplace transformation of 1 is equal to 1 over s. Okay. Now look at this. What if your f of t is equal to k? Meaning if I ask you to find the Laplace transformation of any constant k, so I can say that since it is constant k, I can say that Laplace transformation of k is the same thing as the k. K is a constant. I can bring it out just like doing it like this. I can say that it's the same thing as the integral from 0 to infinity exponential minus stk dt. Since this k is a constant, we bring it out is the same thing as k integral from 0 to infinity exponential minus st dt. So what is this? Just like the Laplace of what? Of 1. So I can say it's the same thing as k Laplace of 1. And what is Laplace of 1? So that's the same thing as k 1 over x, which is the same thing as k over s. Therefore, the Laplace of any constant, for example 25, will be what? 25 over s. If I ask you to find the Laplace of 4, the Laplace transform of 4 will be what? 4 over s. That's for constant. So that's how we do what? Laplace transformation. But let's try to solve more questions on different functions. This is if f of t is equal to 1, f of t is equal to any constant. But what if it is an exponential? Look at it. You have find the Laplace transformation of exponential at, meaning f of t is what? Is exponential at. Okay, now I can say that the Laplace transformation of exponential at, according to the definition of Laplace, is the integral from 0 to infinity of exponential minus st times my f of t, which is exponential at dt. Okay, now from law of indices, I can say what is this? The same thing as the integral from 0 to infinity exponential minus, look at it, from law of indices, if the bases are equal, you add the power together. So adding the power together, going straight to the point, I can say minus into bracket s minus a close bracket t. Okay, now I want to integrate this with t. The integration of exponential function, you should be able to do that, is equal to, if you integrate this, how do we integrate it? You first differentiate everything on this exponential with respect to t. So that will give us minus into x minus a. Take the inverse of it, that's 1 over minus into s minus a. Okay, now write what you differentiated back, what you integrated, minus, the shortcut now from calculus 100 level, t. Okay, now I've integrated that, boundary 0 to infinity, but don't forget our boundary is with respect to t, so the boundary is for t. So I can say what is there is the same thing as 1 over minus into s minus a into bracket exponential minus into s minus a infinity minus exponential minus into s minus a is 0. Now infinity times everything here, infinity, minus infinity, exponential infinity is what? Is 0. Since exponential infinity is what? Is 0, then I have it to be what? I have to be 1 over minus into s minus a into bracket is 0 minus everything here times 0 is 0. Exponential 0 is what? 1. So if this bracket give us minus 1. If you multiply this minus with what is there, I have it to be what? 1 over s minus a. Therefore, the Laplace transformation of exponential at is equal to 1 over s minus a, where a is what? Our constant. Here you get, the a is the constant there. Similarly, I can now say that if you are asked to find the Laplace transformation of exponential 2t, by comparison, that would be 1 over s minus 2. A is 2 by comparison. Also, if I ask you to find the Laplace transformation of exponential 7t, then we should know that would be what? 1 over s minus 7. What if I ask you to find the Laplace transformation of exponential 1 over 2t? 1 over 2t is the same thing as 1 over x minus 1 over 2. Shall you get? But what if I ask you to find the Laplace transformation of exponential minus 2t? By comparison, my a is minus 2. So that will be 1 over s minus 2, which is the same thing as 1 over x plus 2. Shall you get? Also, if I ask you to find the Laplace transformation of exponential minus square root of let's say 3, then the answer will be what? The answer will be 1 over s plus square root of 3. So that's how we find the Laplace transformation of what? An exponential function. Okay, let's try to solve more questions. Let's see. What if you are given find the Laplace transformation, what if you ask to find the Laplace transformation of cos AT? Okay, now we can solve this using two different methods. We can use the exponential form of cos, meaning the Euler form of what? Cos AT, or we can use integration by part. Okay, so we can just go straight to the point by saying what is there by definition is the same thing as the integral from 0 to infinity of exponential minus st cos at dt. Now, you know, to integrate this, we have this to be integration by part. This is my u, this is my what? dv. Then you apply integration by part, but at least you have to integrate it twice. So if you integrate it using integration by part, when you integrate twice, here you get, then the answer you'll be having from that integral is exponential minus st over x squared plus a squared into bracket a sine at minus s cos at, close the bracket, close it, then I have my boundary from 0 to infinity. When you substitute the upper boundary and lower boundary, my final answer is s over x squared plus a squared. So we have Laplace. What you just have to do is know the definition, substitute it into it, then we are free to what? We are free to go. So that's what we call Laplace transformation. But before moving into the next topic, there are some, let's call it elementary standard Laplace transform. Just something like standard technique. Let's call it elementary standard Laplace transform. So if this is your function, if what is at this part is your function, when I say function, I mean this is f of t, and at this part you've taken the Laplace transform, Laplace transform. So I can see this place is L of f of t, or sometimes I can call it f of s, because it shows that you are taking the Laplace of what is at the right hand side. So if you take the Laplace transformation of 1, the answer is 1 over s. If you take the Laplace transformation of k, the answer is what? K over s. You have to know that, so that it's going to what? Help you when you are solving your question. If you take the Laplace transformation of exponential at, then the answer is what? 1 over s minus a. If you take the Laplace transformation of sine at, let's just take it as standard techniques. This will give us a over x squared plus a squared. Here you get, okay. If you take the Laplace transformation of cos at, that would be s over x squared plus a squared. If you take the Laplace transformation of t is 1 over s squared. The Laplace transformation of t raised to power n, that's n factorial over s raised to power n plus 1. Also, if you take the Laplace transformation of cos at, that's the cos hyperbolic of at, that will give us s over s squared minus a squared. Look at it, it looks alike with this. The difference is just that this is plus, this is minus. And what if we take the Laplace transformation of sine, that's sine hyperbolic function of at, that's a over x squared minus a squared. So we have a lot, but at least these are the common ones we'll be seeing frequently. So you can just master the standard techniques, and in our next video we'll look at examples generally on what? Laplace transformation. Thank you.